Sorry, everybody. Thank you so much, Dimitri, for your time. Sorry for the problem with the mic again. And yeah, today, Dimitri, our good friend, will give us a small lesson into the deep mysteries of MEV. So everybody be ready. And yeah, let's do this, bro.
Right. Yeah. So you're seeing this. Let me just click play. You can see it fine, right?
Very clear.
Okay, cool. Right. So I decided to do sort of everything about that, everything, because there are pretty much tons of repositories available for you to learn on GitHub, where you can read the code, various bots, including the DEX to ARP, liquidation. So I decided to go a bit a different way and just tell you more about where to think, how to think, and what can you use to be successful in 2023. As obviously you know, MEV is getting more and more complex. Lots of generalized front runners, people using various technologies to actually be the first ones to submit the bundle, to land the bundle, etc., etc. So, right. So we're gonna talk about generally first about the RPC client, as probably you would know, and I would assume most of you guys are using public nodes or any paid versions of public nodes. Let's say Alchemy, you can buy yourself a slot, but that won't be entirely your node. So it will still have a bottleneck of in the busy times, let's say when the people send many requests, they can overload the node, and your responses will be pretty slow, which is extremely critical for you as you're trying to solve something fast, especially in the faster blockchains, like if we take Polygon or AVAX or anything that is fast enough, even Binance Smart Chains, 3 seconds block, right? So your general objective will be to minimize the amount of ETH calls you send, at the same time keeping the entire state of keys that you need in order to execute your strategy somewhere either in memory or cached. So for that reason, I do propose you a solution by storing the state on your machine. So what am I doing normally for anything I do? Not only even related to MEV, but it could be also CFI, DeFi, ARP. Could be anything where you interact with smart contracts. There is a great library called REVM, which allows you to simulate any transactions, any interactions with Ethereum blockchain. So it works the following way. You create accounts, you populate accounts inside the REVM object with storage slots with corresponding keys, everything very familiar to those who know EVM. And it allows you to simulate the transactions pretty much like you would fork a blockchain via Foundry, via Anvil. You would fork it, and then you would try something out, right? So pretty much Anvil is actually under the hood. Anvil is REVM with tweaks. Let's put it this way. So REVM provides the execution layer, and you can simulate locally everything. And it has a in-memory database, which is, as far as I remember, it is a trait. So you can re-implement it your way if you think you can do faster, which in fact I did, because they are using the in-memory But if you are, let's say, doing DEX-to-DEX ARP, you need to keep track of, let's say, 2,000 pools and the reserves. Then you wouldn't probably want to have it in memory. You would want to store it somewhere. And for that reason, there is a great library in Rust called CA Cache, which is extremely performant library. I believe initially was written in C. Obviously, as you already could have guessed, I'm using Rust pretty much for everything I do, as I do like the performance and I do like the zero abstraction concept. So let's have a look. Yeah, for sure. Let's have a look on the GitHub of REVM. So when I first saw this repository, there was pretty much nothing in terms of examples or any good README. It was pretty naked, let's say. So I tried figuring out myself. I spent a week trying to understand how it works. And the funny bit, actually, there is a guy called Degachi. You probably know him from the same group. So he was doing exactly the same thing as me at the same time when we were chatting over Discord, whether who understands it first and share some say secrets and how it works. So once I learned it, I created the example, which in fact is the only one example for now, which you can find and learn from it. I tried to put as many comments as I could. So as you can see, it even actually this library has like also a mod, let's say, that allows you to copy the state of the account. So pretty much get storage add, but with a few sugar coating, so it is nicer and everything is already passed. So you can see there we download EthersDB. That's the name of the DB. Actually, I wrote this DB as well for REVM. So basically, just getting the account, basic properties of the account, including the bytecode. It gives you the bytecode straight away, which is nice. Then we queried our value at our desired storage. So plot 8 is the reserve for UniV2 like pool. And then we store it into the cached DB, which is in fact in memory DB, not the cached on your hard drive. We insert the account, blah, blah, blah. Then we create the EVM object, initialize and add the DB to the EVM object, and then we can transact. So in order to transact, we need to create basically fill the basic fields: caller, transact to, data that you would want to send, the transaction data, so call data, and the value that you would want to send as well. And then you pretty much have an option to either transact ref, which will return you the result of the interaction with the EVM without writing to the database. Or you can do just transact. So without the ref, that would be the actual execution plus the recording in your REVM database. So if you simulating something and that includes a few lifespan of several blocks, let's say, then you would want to transact and record for obvious reasons. And by learning this tool, you will be able to do crazy stuff. By crazy stuff, I can tell you that in order to arbitrage, like DEX-to-DEX arbitrage, let's take the simplest example, UniV2, no tick liquidity, nothing really fancy. It's pretty easy to implement the get amounts out. Everything can be re-implemented very easily with any language off-chain, so you don't have to send these ETH calls all the time. But what if I tell you that you can pretty much make something that is completely agnostic of how the protocol works, and at the same time gives you the desired result? And for that reason, there is an REVM, because you pretty much don't need to know how Uniswap v3 calculates the fee or whatever it does inside. All you need to do is to find the methodology, how you can use the REVM, what storage slots you need to copy to simulate. And then all you need to do is just binary search it. So you're literally brute forcing the outputs, sorry, not outputs, the inputs, because you know what output you want to see. So REVM does help you to standardize pretty much any strategy, given that it can execute, I believe, million iterations in under 1 second. I think, 1 millisecond. 1 millisecond, sorry, not even second.
That's crazy, bro.
This thing is extremely powerful. There is also a good Telegram chat in REVM, official one, so all the maintainers are there. I'm there as well. So if you guys have any questions, feel free to hop there. Very smart people there, especially Dragan Rakita, who actually wrote REVM initially. And now it is a core block for Foundry, and it is a core block for Ethereum as well. So the Paradigm client, they actually use many of the logic from REVM there. So that was my biggest, let's say, biggest finding, and the thing that actually have helped me to improve a lot, because initially I started with Python, which was extremely slow. Obviously, I wasn't able to capture anything. So I had to readjust, and people obviously learning fast, and especially those who already were doing it for a while, things that I was trying to do were just completely outdated, and anything that is publicly available is obviously not going to work now anymore. So those are just for you to actually learn and understand what are they trying to do, rather than copy and try to replicate something. So the second thing that I kind of found to be a bottleneck for me when I was trying to do the Polygon DEX to DEX ARP, as blocks are extremely fast, and I was trying to target as many DEXs and as many pairs as possible. Obviously, robust filtering is very important, and I would highly recommend when you filter pairs. I remember there was a guy who was doing the MEV talked about DEX to DEX ARP in Go a few weeks ago, I believe, and he was using Graph, which really did surprise me, to be honest, because I've never seen anyone using Graph. I'm not saying it's bad. I was just never thinking about it. So I was initially I just wrote like a very small flat query contract that gets you reserves or pairs in batches, but that will lead to spamming the RPC node. And if you do have any other processes communicating with the node, you would rather not do it, because that can slow it down, even if you have a private node. So for that reason, I thought, wow, okay, why would I update everything every time if I can just run the first update that would update every single pair, and then after that I would just find the signal for those pairs that actually are touched and the reserves potentially changed, and just refetch those exclusively. So for that reason, I decided to pack logs, just look into logs of the block, and extract all the addresses, and create launch a future basically to actually fetch for each object individually. As you can see on the right hand side, the first code snippet on top is actually pretty much the entire logic for the update that consumes the vector of logs, pretty much sorts them out for unique addresses in a hash set, and then pushes the pair.update, which is a method you can see below, which is a method on the pair itself, and it yields the future together with writing for the reserves into the reserve slot of the pair. So with that way, you're able to very quickly execute the entire update of those pairs that you have to update because they've been potentially touched in the logs. And you save a lot, as you only need to send 5, 6. Not normally, as was what I saw is even in a very, very quick market conditions when we see huge price appreciations or depreciations, maximum 20, 30 in a block. So so that's not a lot, right? So it is pretty easy to fetch. And moreover, you can even improve this algorithm by, for example, using the batch call. So you can pack them into one single batch call, which will normally be fine, as most of the RPCs allow you to send batches of 100 via WebSocket, and I believe 200 via just the normal RPC connection. So, this idea can be used pretty much everywhere. So not only related to DEX ARP, you can, and you have to use pretty much the same concept for any strategy that keeps track of some storage keys in the account, and it emits any of the events, so you can see it in the log. So definitely do look up into logs and utilize logs properly. And there is also a side note that subscribing to logs, sometimes you can, some libraries allow you to subscribe to logs, or you can write your own and subscribe to logs. But I found some problem with that, as sometimes if the node is very busy and the new logs are in the queue, basically two portions of logs are in the queue, then you will only listen and receive the latest one. So you can skip the entire chunk of logs, which is bad. So that's why I decided to actually send specifically the request for logs and then process it. So I'm targeting more like block heads rather than the logs themselves. Rust for the win. That's for sure. I tried Go, I tried TypeScript, Python, whatever. Nothing is as fast, as robust as Rust. And given the amount of libraries, like Ethers.rs is the best library pretty much for Ethereum I've ever seen. And I've tried a few in many other different languages. It might sound funny, as obviously Geth is in Go, and Go should technically be the best lib, but our Ethereum, Ethers.rs is just so well designed, with such a great support in Telegram as well by the guys, both Georges and James Press, which anytime can help you. Any even stupid questions, which initially I had, because Rust is pretty tough, and learning Rust and learning Ethers.rs at the first place wasn't as easy as I initially thought. I don't know, some of you might be aware that the fastest searchers, I'm not sure if they still do it, but they used to do it for sure when Ethereum was proof of work. They were actually forking the Go Ethereum client same way as Flashbots did. But in fact, they were changing the client to actually embed, like to have their own bots logic. So you're pretty much making a client that executes the transactions that you want to execute. So I don't know if anyone is coming from TradFi or know something about FPGAs, which is like field programmable gate arrays. So kind of produced hardware that already has predefined set of instructions. So that's the fastest you can be. to execute anything pretty much anywhere. I'm unfortunately not very proficient in hardware, but FPGAs is definitely a thing in TradFi, and I believe that more and more people will be moving to forking GEF, and maybe, and potentially, not even maybe, and I think soon it's going to be our Ethereum that will be forked and modified to actually process the transactions for the strategies that searches run. So our Ethereum is definitely the newcomer, and it will stay and it will develop into something big, I believe. So for that reason, I think Rust is all you need to have pretty much from the off-chain, let's say, languages. So yeah, it covers both our Ethereum, which is consensus and execution, and then there is like a REVM, which just executions you can simulate and caching. Then Ether's RS allows you communication with RPC. So Rust is definitely the way, and for that reason, I will share as well a very great channel for Rust that helped me a lot to actually learn it. Once you read the Rust book and know the core concepts, then I would highly recommend you watching these videos. They are very long, and don't get discouraged, but they're incredibly informative. And that is designed to be something intermediate kind of level. So you have to have basic understanding. So the guy is pretty much re-implementing the standard library from scratch for most of the things, how ARC, atomic referencing work. And that's extremely important. So you write the good, coherent, and efficient code. And going back to this. How to win. How to win. Basically, if you're reading it on crypto Twitter, it's too late, bro. Like, most likely you're never gonna find something on crypto Twitter or anywhere else, any public resource, and replicate something so that you make money. So the best approach for me has always been doing my own research by inspecting and reading new protocols in DeFi space, or even in gaming space sometimes, that come to the market before anyone actually sees it, maybe even in earlier stages, not even mainnet stages. Then understanding briefly understanding the concept, understanding what is what, and asking yourself a question if you can somehow profit by reordering something or putting your transaction before or after the user's transaction. And after that, you would obviously read the code and understand if those functions external at all, or can you call it actually, can you read something? And then pretty much jumping straight away into implementation. And because you have REVM, you can simulate anything. So, but at the same time, don't spend too much time on implementing something and then making it live, because some other people can find it earlier and you will be kind of in disadvantage or maybe even discouraged of doing that. So I would highly recommend to write a fast prototype and then build on top of it, because you will clearly see when your bot is live what is actually lacking. Are you lacking speed, or maybe you need better filtering, better signal processing, or whichever it can be. And it's important to take the entire opportunity as well. So I saw, like, we can clearly see, especially with those who actually brute force the outputs the standard way, let's say, how they brute force the outputs for the uni. And they sent, and I think this guy was actually saying the same thing, that he was sending one Ethereum for each of the arbitrage opportunities he finds. And then sometimes he can even create another arbitrage opportunity because it was too much. So finding and an opportunity is one thing, but optimizing the code in such a way that it covers the entire arbitrage, not more and not less, is essentially your main goal, because then it will be much harder to see and find the opportunity. Only if the guy actually like sees you actually executing transactions, then he can pretty much copy you or think how he can outplay you. And don't, yeah, that's what I said. Don't implement something that is like been on the market for a long time, like DEX-to-DEX ARBs, liquidations, and sandwiches. Because if you are starting, most likely, I mean, not even most likely, for sure, you're not gonna be able to compete with the people who's been doing that for a long time. So don't do something that so many searches are already doing, unless you definitely know you have an edge that will give you a good competitive advantage, and you will be able like to actually get something out of it. Because you're probably aware that most of the time for DEX-to-DEX ARB or liquidation or sandwich, you're gonna pay like 99% of the fees or of the profits to miners as a coin-based transfer. So like it's pretty much a fee for them to actually execute you. So the potential profit is relatively small right now, especially right now in a very stale and slow market. Unlike when you can invest time into researching something more interesting and something that no one does. And I remember I was doing like a few of NFT stuff. NFT MEV was pretty good, especially when the market was very active. So when we had like so many mints every day, and sometimes people list stuff at the ridiculous levels, and then there is a public sale next day. So you can literally, all you need to do is mint on the public sale and sell into best bid. That was the case as well. Then there was even longer ago, there was a rebase, like Olympus DAO. Everyone knows this stuff. So Olympus DAO wasn't as crazy as some of its forks, especially on Phantom, that were giving you like 5% or 7% on rebase, each rebase. So you could have just swapped for their token, stake it just before the rebase, trigger the rebase, unstake it together with the collected rebase, swap it back to what it was, so USDC or ETH, and check for balance in the end. So if you're winning. So those kind of things are much less competitive, and harder to find, obviously, and unfortunately they don't last long. That's the biggest drawback. So I am currently working more on generalized kind of bot, but it's very early to actually say something, and because I'm not really sure if it's gonna work. Yeah, and the key is just keep using REVM. Is really like, I cannot stress it enough how important it was and it is in everything I do, including DeFi to CeFi trading, logs as well. So I'm open to any questions. If you have any questions, you can always reach me on Twitter, GitHub, Discord, same nickname everywhere, or even email, same email, proton.com. Any questions you have, definitely do ask. I'm more than happy to help anyone. And if anyone has any questions now as well, feel free.
Thank you so much, bro, for that. And anyone questions?
So I do have a question. It's like regarding the morality and the legality of all this, in that it differs from where you live, but how do you deal with all of that? I don't know where you live, but how can you? Is there a resource to find all that and so forth?
The resource for legality and morality. I mean, I'm just a libertarian person who thinks that if anything is not illegal, then it's sort of legal. So it doesn't contradict to my values, basically, and I don't think it breaks the law where I live. That's kind of my approach. I'm not saying anyone should follow it, but I'm kind of a DeFi native.
Got it. Thanks. Yeah, it doesn't go against my morals either, but I'm more interested in legality in specific.
Yeah. Be very careful. Actually, that's a very good question. Be careful because if you're using like something like Alchemy, Infura, all of these guys are sending your IP addresses and saving them. So you can easily be discovered. Basically, if you're doing something shady or I don't know, your bot, I don't know, hacked. If you wrote to generalize something and you front run the hacker, then you can have problems with that. So I would definitely recommend you running your own node. Your own node is always a great solution, or using a service that provides you like a Tor relay. There is like a service called ZMOK.io. They actually have you can connect via Tor. So onion router, right? So I don't know how safe is it, but definitely do research and see, especially if you live in the United States of America, where you can, you can be caught, and even if you did something unintentionally, it's better to be safe, basically.
Yeah, thank you for that.
Anyone else?
On the topic of legality, have any MEV bots actually been prosecuted? I haven't heard of anything like that happening at this point.
No, me neither, to be honest. I've not heard anything. I'm pretty sure if it has happened, then we would have known from Twitter, because Twitter is kind of spreading everything.
Yeah. All right. Thanks.
And also, by the way, I will be able to send a list of good resources that I think are useful, just to a Discord chat, let's say, as a list, or as a bookmarks export or something.
Money Group, Claudine, Kuririn, Buddy, Jet. Dmitry, I think this is it, bro. Thank you so very much. That was beautiful. Probably the first real MEV class someone ever gave. Thank you so much. I'll link you everywhere. I'll link you on YouTube and on Twitter. And yeah, thank you so much, bro. You fucking killed it. Okay?
Yeah, thank you, bro. Very happy to join you guys. And next time we're just gonna go deeper in more topics. So probably I'll just make a questionnaire or something in the topics that most of the people would want to know. So obviously for obvious reasons, I can't say everything that I know.
I understand.
But yeah, I definitely can show things up and at least direct people into right direction, basically.
Thank you for the alpha, bro. Okay?